You walk into a hospital needing blood. It should be simple. Doctors check your type. They find a match. The bag goes up, the line goes in, and you walk out fine. But for a tiny number of people on Earth, that simple moment turns into a crisis. Doctors check their type. They find a match, and the transfusion almost kills them. This isn't a rare disease. It isn't a virus. It's blood, your own blood, doing something almost no one else's does. To understand why, you have to forget everything you think you know about blood types. You learned it in school. A, B, A, B, O. 4 boxes. Simple. Except those 4 boxes were never the whole story. They were the surface of something much deeper, something hiding inside almost every red blood cell on the planet. And in 1952, in a city then called Bombay, that hidden layer finally showed itself. A physician named Dr. Y.M. Bende was running routine blood tests. One sample refused to behave. It didn't react like type A. It didn't react like type B. It didn't even react like type O, which is supposed to be the universal donor, the blood everyone can receive. This sample attacked everything. It clumped with A blood, it clumped with B blood. It even clumped with O blood. As far as this patient's immune system was concerned, every other human being on Earth was foreign. Bende brought in outside experts to confirm what he was seeing, including researchers Ruth Sanger and Robert Race, 2 of the most respected names in blood group science at the time. Together, they confirmed it. This wasn't a mistake. It wasn't contamination. It was something new, a blood type sitting underneath the ABO system, one that had been there the entire time, quietly overlooked. Here's the part your biology class skipped. A and B antigens don't build themselves from nothing. They're add-ons, decorations. Underneath every A antigen and every B antigen sits a foundational molecule called the H antigen. Think of the H antigen as a blank flagpole standing on the surface of your red blood cells. If your body adds a certain sugar to that flagpole, you get an A flag. Add a different sugar, you get a B flag. Add both, you get AB. Add neither, and the flagpole just stays bare. That bare pole is what type O actually is. But what if there's no flagpole at all? That's the Bombay phenotype. No pole, no flag, nothing for A or B enzymes to even attach to, because the foundation itself was never built. Researchers eventually traced the cause down to a single gene, FUT1, which carries the instructions for building that flagpole in the first place. In people with the Bombay phenotype, both copies of this gene are broken, not damaged, not weakened, silent. The molecular machinery responsible for constructing the H antigen simply never switches on. Biochemists William and Winifred Watkins spent years mapping exactly how these sugar chains get built. Sugar by sugar, enzyme by enzyme, work that helped explain precisely where the Bombay pathway breaks down. Their research showed that the ABO system isn't really 4 blood types. It's a chain of construction steps, and the Bombay phenotype is what happens when the very first step in that chain never happens at all. So why does this turn deadly in a hospital? Because your immune system doesn't just recognize what's missing, it manufactures weapons against it. If you have type A blood, your body makes antibodies against B. If you have type B blood, your body makes antibodies against A. If you have Bombay blood, your body looks around, notices there's no H antigen anywhere, and does something far more aggressive. It builds antibodies against H itself, the universal foundation, which means it builds antibodies against A blood, B blood, AB blood, and O blood all at once. Every other blood type on the planet becomes a threat. Picture a security guard trained to recognize one specific uniform, one specific badge. Now picture a guard who was never shown the uniform at all, so he treats every single person walking through the door as an intruder, no exceptions. That's the Bombay immune system. It isn't confused, it's thorough. It has simply never seen the badge that everyone else is wearing. This is why the phrase universal donor quietly falls apart the moment you meet someone with the Bombay phenotype. Type O blood, the one doctors reach for in nearly every emergency worldwide, is lethal to them. Not slower to work, not less effective, lethal. A transfusion reaction in a Bombay patient can trigger the destruction of red blood cells within the bloodstream itself, a medical emergency called hemolysis. and it can happen within minutes. How rare is rare? In most of the world, the Bombay phenotype shows up in roughly one person out of every 250,000, but it isn't spread evenly. In parts of India, particularly regions with a history of closely knit communities and intermarriage within small populations, the number climbs dramatically to somewhere around 1 in 10,000. The reason traces back to genetics itself. This is a recessive trait, meaning you need a broken copy of the gene from both your mother and your father. In small, tightly connected communities, the odds of two carriers meeting and having children rise sharply. It's not a curse of geography. It's a mathematics problem written into family trees. Which raises an unsettling question. If you can't receive blood from 99.9% of humanity, where does your blood come from? From each other. Bombay phenotype communities across India and Pakistan have built informal networks, registries, and word-of-mouth systems specifically to track down other Bombay donors in emergencies. Blood banks in these regions sometimes maintain rare donor files, listing the handful of known Bombay individuals in an entire state. When someone with this blood type needs surgery, hospitals don't just cross-match. They start making phone calls, sometimes across cities, sometimes across state lines, searching for another person whose blood was built exactly like theirs. There's something almost poetic hidden inside that scramble. In a system built entirely around difference, around A versus B, positive versus negative, donor versus recipient, the rarest blood type on Earth survives only through radical similarity. A Bombay patient in Mumbai and a Bombay patient in Karachi have almost nothing in common on paper. Different country, different language, different life entirely. But biologically, at the level of a single missing molecule, they are closer to each other than either one is to their own siblings. And this is where the story stops being about blood and starts being about something bigger. Every human classification system, whether it's blood type, race, nationality, or tribe, tries to sort people into clean categories. AB, ABO. 4 boxes. Easy to explain, easy to teach. But biology has never actually respected those boxes. The Bombay phenotype proves it outright. It exists entirely outside the 4 categories most people assume are the only categories that exist. It's a reminder that the boxes were never the full truth. They were just the most convenient truth, the version simple enough to fit on a hospital form. Modern genetic testing has only deepened this picture. Researchers have identified numerous distinct mutations along the FUT1 gene, scattered across different populations, meaning Bombay phenotype isn't even one single genetic story. It's several different broken paths that all lead to the same missing flagpole, different roads, same dead end. Nature didn't design one way to erase the H antigen, it found several. There's also a subtler cousin to this condition, known as the para-Bombay phenotype, where the H antigen isn't completely absent but drastically reduced, hidden just enough to occasionally slip past standard hospital tests. Physicians have documented real cases where these patients were misidentified as ordinary type O, right up until a transfusion reaction revealed the truth the hard way. It's a quiet warning embedded in the data. The most dangerous mistakes in medicine aren't always the loud ones. Sometimes they're the ones that look, on the surface, exactly like everything normal. Step back from the biology for a moment and look at what this blood type actually represents. You spend your life being sorted. Height, weight, income bracket, blood type, personality type, generation label. Every system promises to explain you in 4 letters or fewer, and most of the time, it's close enough. It works, until it doesn't. Until you meet the one thing that quietly sits outside every category built to contain it. The Bombay phenotype isn't a flaw in the blood typing system. It's a flaw in the assumption that any system is ever truly complete. It was hiding inside human veins for the entire history of medicine, unnoticed, unnamed, until one sample in one lab refused to fit the chart. And the moment it did, an entire hidden layer of human biology stepped out of the dark. So the next time you walk into a hospital needing blood, and it really is simple, and the bag goes up, and you walk out fine, remember what that simplicity is actually resting on. A hidden molecular foundation you never think about, quietly holding your entire blood type together. For most people, that foundation just works. For a rare few, scattered across a handful of communities on Earth, it was never built at all, and their survival depends on finding the only other people whose blood was built exactly the same broken way.